Welcome back. Today we are going to be talking about solving quadratics when a is not equal to 1. And by a, I'm talking about the number or coefficient in front of the x squared. Recall the uh, standard form is ax squared plus bx plus c. And so here our a value is 3. So it's going to work a little bit differently when we solve this. We're not going to take just a straight up guess and check method for this because we start adding on a lot more possibilities to have to guess and check. But we can what we can do is we can't necessarily eliminate all the guessing and checking, but we can reduce it or make it a little bit easier upon ourselves. So let's go ahead and do this. I'm going to start off when I see a problem like this, where my a is not equal to 1. I'm going to look at my a value and my c value, and I'm going to multiply those together. So I'm going to say a times c, and that's going to give me 24. So on the side, this is scratch work. You don't do this on your paper. You just kind of do this on the side or on a separate sheet of paper. And so this is a times c, and here is our b value. In this column I have my b value, which in this case is -10. So what I'm looking for are multiples of 24 that add to -10. So it works kind of the same way, except we're having to multiply a with c, whereas we didn't have to do that before. Well, we were still doing it, but it was just with 1. Anyway, so let's see. We could try, well, I'm going to analyze my signs first. So I see I have a plus sign here, and this is a negative. So this tells me that my signs are going to be both the same sign. Okay, the second one tells me it's positive, so it's going to be either both negative or both positive. And this negative here tells me that the signs are going to be both negative. So we can go ahead and start. Let's try, well, if I did, let's say, -3 and -8, so -3 and -8, so they have to add to -10, but in this case, these add up to -11, so that doesn't work. I could try -2 and -12, so -2 plus -12. Those multiply to give me 24, but they add to give me -14. Okay. I could try -6 and -4, and that gives me -10. I have a winner. Okay, so I'm going to go ahead and, now that I know what my numbers I'm going to be using, which is going to be a -6 and a -4, I'm going to rewrite this trinomial into a quadrinomial. In other words, 4 terms. So I have 3x squared. Okay, now what I'm basically going to be doing is taking this -10 part, and I'm going to be breaking it into 2 different terms. Here, let me get rid of this so I have room to work with. So the -6 and the -4x, because they have to add up to -10. So this is going to become -6x and then plus -4x. So we're not going to change the value of -10. We're just going to rewrite it. So over here, instead of writing -10x, I'm going to put my -6x and -4x. Now, you may ask, well, which one goes first? It doesn't matter. I could have put the -4x and then the -6x. So, again, it doesn't matter. And then I'm going to put plus 8. All right, so here's where So it's plus negative. So here's where I'm going to start factoring. I'm using a method called factoring by grouping. So the reason why I had turned this into 4 terms is so I can group the first 2 terms together and then group the second 2 terms together. And when I look at this, I'm going to look at, say, okay, well, what is my greatest common factor between negative 3x squared and negative 6x? And that would be a 3x. They both have at least a 3x. So I'm going to factor out a 3x. And I'll be left with, so when I factor it out, it's like when you multiply something in, you distribute it in. You multiply when you distribute. When you factor it out, you divide it out. So I'm divide 3 by 3, that's going to leave me with, 1. So the 3's cancel. And then I have an x squared, and I'm factoring out an x. That's going to leave me with a single x. And then minus 2. Because 6 divided by 3 is 2, and I factor out an x, so there's no x's left. Next, plus, this next one, I can pull out a 4. Now, I want this first term here to be positive, so that means I need to factor out a negative 4. So if it's negative, factor out a negative. So I'm going to factor out a negative 4, and then I'm left with an x. And then that plus 8, since I'm factoring out a negative, changes to a negative 8. It's like dividing by a negative, minus 2. And if you did it right, you'll notice that this term and this term are the same thing. And so we can view this as a, one big term. And I say, okay, well, I have one, actually 2 terms, and I have 1 term here, and I have 1 term here. And what do I have in common? Well, these both have a x minus 2. So I'm going to factor those out and put that up front. So I have an x minus 2. So I factored those out, and then I no longer have them in here, so I'm left with a 3x and a negative 4. So then I just write what I have left, which is 3x minus 4. And now it's factored. So that's what I would box in. Okay. So that's just our first example by factoring by grouping when a is not equal to 1. Let's take a look at another one. Since that was just the first time seeing that, let's see what it looks like if we do with a different one. Okay, so it's still the same process. I'm going to multiply a with c. So that's going to give me a, let's see, negative 90. So I'm looking for factors of negative 90 which add up to our b term, which is just 1. So let's see. This minus sign in front of the 15 tells me the signs are different, and the plus sign tells me that they are, well, larger number is probably going to be positive. So let's see, we could probably do, well, how about negative 9 and 10? That gives you negative 90. You add it together, and it gives you 1. Hey, we got it right away. So, and it gets easier with practice. The more you do, the easier it gets. You start spotting patterns, and then you can do it without having to put much, work forth. It just comes with time and practice. So, we got 6x squared, and then I'm going to pull out I'll just do the 9x first. Again, it doesn't matter. And that'll be my first grouping. Plus, and then 10x So add those together, it gives me the 1x. So I'm not changing the value of that middle x. Minus 15. All right, so I look at the first grouping and I say, well, what do they have in common? What can I factor out? And I can say, well, I can pull out a 3x, which leaves me with a 2x minus 3. Okay, if I do this right, the second one, what's left in the parentheses should be the same. So I can pull out a 5 here, which leaves me with 2x minus 3. And we got the same thing in the parentheses, which means I can factor that out, leaving me with just 2x minus 3. And then what do I have left? I have a 3x and a plus 5, so my next factor is 3x plus 5. So I can see that those factor out nicely. And that's what we get. And of course we could check our answer by multiplying those back together and see if we get the original trinomial that we started off with. Okay, so there are here are our special factoring patterns that we talked about before. The difference of squares, we have two squares that you're subtracting, and the two perfect square trinomials where you have the first and the last term are perfect squares, and the middle term is twice the square root of those two, or 2ab in this case. Well, let's take a look at these special patterns with our new trinomials or new polynomials where our coefficient in front of the x squared is not necessarily 1. So looking at this one, I can say, I would ask myself, all right, I just got a mess of polynomials. Let's say I'm just factoring. It doesn't tell me if it's special product or not. And I just see something with two terms. And I'm going to ask myself, well, if it's two terms, then this might be a difference of squares. So I would look at the first term, the 81x squared, and say to myself, well, is that a perfect square? And I'd say yes, because 9x times 9x gives me 81x squared. Then I would look at the second term and ask myself, well, is 25 a perfect square? And I'd say, well, yes, it is. It's 5 times 5, or 5 squared. So, and then I would verify, is there a minus sign in the middle? And yes, it is. So really, this is a perfect difference of squares. So I just write, oh, this is going to be 9x plus 5, and the next one's going to be 9x minus 5. And once I verified it's a special product, it's a piece of cake to factor. So here would be another case. Here's another example. So I'd say, okay, I got three terms here, and I'm always checking, is it a special product? Is it a special product? And I'd look at my first term and I'd say, okay, well, I got 9r squared. Is that a perfect square? It is, because that's 3r. The square root of that's 3r. 3r times 3r is going to be 9r squared. And then this next term, 121, is that a perfect square? Yes. That's 11. And then the middle term, is that going to be 2 times our first term times our second term? Is that going to be 2 times 3r, 3r times 11? Well, 3 times 2 is 6, times 11 is 66r, and that matches up here. So yes, it is a special product. So when I write my answer, my factors anyway, it's going to be 3r. Okay, it's a minus sign and a plus sign, so that tells me that these are going to be both minus signs. So I just say, oh, that's going to be 3r minus 11 times 3r minus 11, or we could just simply write it as 3r minus 11 squared. Just like that. Okay. Our next example, which actually should be example 5, is, I would look at this and say, oh, well, is this a difference of squares? And I'd look at my first term and say, is that a perfect square? And I'd be like, well, no, it's not. because there's no number times itself that'll give you 3. Well, is it prime? Does it mean we can't factor it? And the answer to that is, well, actually we can factor it. Before you start doing any, factoring or guessing and checking or checking for special products, make it your priority to start looking for GCF, greatest common factor, and look for that first. GCF first. Because in many cases when you don't think you can factor it, there might be a GCF that you can pull out. Or even if you can factor it with a GCF, you should pull that out, first, because you're trying to find all the factors. So we're going to do the GCF first, and I can say, well, is there a common factor between these two that I can factor out? And the answer would be yes. In fact, I can pull out a 3 from both of these. So I'm going to factor out a 3, which leaves me with x squared minus 100. Now I look at what I have left in the parentheses, and I see that x squared is a perfect square and 100 is a perfect square, so I can factor that. So 3, and then x plus 10 and x minus 10. 3 is still a factor. You must include it in your answer, because without the 3, you're not going to get the original polynomial. If you just had the x plus 10 and x minus 10, you're going to get x squared minus 100, but not the 3x squared minus 300. So you must include the 3. Many times people don't include it. They just said, oh, they pull it out and then they disregard it, and you can't do that. It changes the problem entirely. Okay, so let's look at another one. All right, 8m squared plus 28m minus 120. So GCF first. Is there a greatest common factor? And you say, well, yes, there is. What can we pull out here? And it would seem like I guess the largest term that we can pull out here would be a 4. Okay, so let's see. If I factor out a 4, I will be left with 2m squared plus 7m minus 30. Okay, so then I'd say, well, is what's left a special product in the parentheses? And I look at the first term and I ask myself, well, is it a perfect square? And no, it's not. There's no number times itself that will give you 2. So then we go to our guess and check. We'll start with a times c. So 2 times negative 30, which is negative 60. And that needs to add to 7. So the minus sign in front of the 30 tells me the signs are different, and one's positive and one's negative. And the plus sign in front of the 7 tells us the larger number is positive. So let's see. 2 things that multiply negative 60 that add to 7. We could do 4 and 15. So let's see, 15 and negative 4. 15 plus 15 plus negative 4. We add that together, and that's going to give me 11, so that didn't work. We could try, let's see, 10 and 6. So positive 10, the larger number's positive. Make the 6 negative, and we add that together, and that's going to be 4. All right, so that didn't work. Let's try another one. We could do 12 and negative 5. Add that together, and it gives us 7. Ah, we have a winner. Okay, so in our next line, in our factoring, we include the 4. You don't disregard the 4. It carries all the way through to the end. And so we're left with 2m squared, and then the 7m Remember, we're splitting that up into two terms. I'm going to do plus 12m plus negative 5m minus 30. Okay, so 4, and then I'm going to group these together. So let's see, I'll group this with this and this with this. I can pull out a 2m from the first term, so I'll factor out a 2m, which leaves me with an m plus 6. And then here, I want the first term to be positive, so I'm going to factor out a negative, and it looks like a negative 5 would be the largest thing I can pull out. So plus negative 5, and then m, because I factor out a negative, it's going to become plus 6. And see, I have a m plus 6 here as well, which tells me, hey, I did that right. So I'm going to bring down the 4. I can pull out an m plus 6 from both of these. And then I'm left with a 2m minus 5. And that is completely factored. Remember, if you don't have your GCF factored out, it's not completely factored. So if it was a quiz or test, you might, you get dinged for that. So especially when you're trying to factor it completely into its simplest terms. All right, let's try another one. Again, it's just factoring is just practicing, and then you get better at it. So, okay, so first thing, GCF first. Is there a GCF? And I look at this and then say, oh, well, there is. I can pull out a 7 and a t, a variable as well. So I'll pull out a 7t, and then I'm left with a t minus 9. And then I look at what I have left and it's like, well, wait a second. T is not squared anymore. And I just have a minus 9. There's nothing left. I mean, this is prime. I can't do anything else with it. So this, just by pulling out the GCF, is completely factored. This will happen from time to time. So the only thing that can factor out is your greatest common factor, and you can't do anything, so that's going to be my solution. Okay? So that'll happen. All right, let's look at one last one. Now this time we're going to solve. So we're not going to stop at just having all the factors. We're going to go all the way and figure out, what is x equal to. We're trying to figure out what is x equal to. So first order of business is we have to set it equal to 0. Okay, it only works if we set it equal to 0. So we will do that. I'm going to rewrite this as 4x squared. So we're going to subtract 17x from both sides, leaving us with negative 17x minus 15 equals 0. And now I ask myself, okay, GCF. Is there a GCF I can factor out first? In this case, no. There's not. 17 is prime, so there's no way. Now I'm going to multiply a times c. So I will be looking for factors of negative 60. That will add to negative 17. Okay, so the sign in front of the negative 15 tells me the signs are opposite. One's positive, one's negative. And the sign in front of the negative 17 tells me the negative number is the larger one, or so to speak. So let's see, we could do 2 and 30, so negative 30 plus 2, well, that's not going to work. That's going to give me a negative 28. We could do a negative 3 and 20. So make it negative 20 because that'll be the larger one, plus 3. And that's going to give me negative 17. We got a winner. That's what we want. So I know how to break up my middle term, how to factor that. So I rewrite this as 4x squared. We'll do the minus 20x plus 3x minus 15 equals 0. So I'll group my first two terms together and my last two terms together. Okay, GCF between 4x squared and 20x would be a 4 and an x, which leaves me with x minus 5. And I can pull out a 3, which leaves me with an x minus 5. So we did that well. Oops, equals 0. I can factor out an x minus 5. Then I'm left over with a 4x plus 3 is equal to 0. Okay, so remember, one of these terms would have to equal 0 to get the whole equation to equal 0. Recall, I don't stop here, and I'm actually solving. So we don't just box this part in. We got to figure out what x is in fact equal to. So I have to go all the way. So this side we do x minus 5 equals 0. And this side could be 0. So what value of x would make this binomial equal 0? Well, this one we just add 5, so x equals 5. And this side I would subtract 3 from both sides, leaving me with 4x equals negative 3. Then we would divide both sides by negative 4. So like this. And x would equal negative 3/4. So therefore, our solution set, x could be two values. So in our set notation, we'll say x is equal to negative 3/4 and 5. And we box that in. So that's how you can factor and solve quadratics when a is not equal to 1. I'll see you on the flip side.